Really? I am far from cliche. Hello, I'm Steve Reed, and this is Steve Reed Chats. This mini-series is all about something that I've always been fascinated by and something that really intrigues me. UFOs, the paranormal, and beyond. Subscribe and turn on your notifications to make sure you know when the next episode is ready to listen to. And I have got some amazing special guests through this mini-series that have some great experiences and stories to tell. So let's go ahead and meet the person I'm going to be speaking to on this episode. He is the Professor of Science at Harvard University in the United States, author of world-renowned books, including, most recently, Extraterrestrial, the first sign of intelligent life beyond Earth. And with all that information whizzing around his head, it's no wonder he's a fan of going out for a light early morning jog when the world around him is generally still sleeping. Hello, Mr. Loeb.
Hi, nice to speak with you.
And you, now, do you prefer Abraham, Avi, or Mr. Loeb?
Avi. You can think of me as a farm boy that just followed his childhood curiosity. All the labels that relate to my career are not very significant for me.
I'm glad you said that rather than Mr. Loeb, because that does sound like the next Bond villain. And I wouldn't want to put that on you. It's a lot of pressure there. Okay.
Yeah, by the way, I don't really care how, what labels people put and how many likes I get on Twitter. I'm not subscribed to social media. So I'm really, as they say in basketball, I keep my eyes on the ball.
And you're not missing much, I'll be honest with you. Now, we got a lot to talk about today, so I'm going to get straight into something that's really interested me. The most recent scientific news I've read about is that Jupiter, the moon, one of the moons of Jupiter, Europa, as viewed by a passing probe, has had a more prolonged vapor emission seen at one of its poles, and it's believed that a mass ocean could be below the surface of Europa. There's also Saturn's moon, Titan, where there's similar evidence of ice or liquid. And there's an interesting ongoing research, isn't there, for quite some time now, of ice found on comets. So tell me about why those discoveries are so significant in the jigsaw for search for potential life in space.
Well, in fact, there is one more example, which is Enceladus, where a recent mission found those geysers, eruptions of jets of water vapor coming from cracks in the ice. And they indicate that perhaps there as well, just like in Europa, there is an ocean under the icy surface. And that's what people suspect, that there is liquid water there. And of course, the question is whether there is life in that liquid water. Maybe there are fish swimming there. Who knows? And the way to find out is, of course, to find obviously you can search with high resolution images for fish, dead fish on the surface of the ice that came from the cracks, but that's unlikely. One way to find out is to search for molecules that are complex enough that they cannot be produced naturally by chance and are most likely indicative of life forms under the surface of those objects. And in order to find those molecules, what you need is a flyby that actually crosses the path of these jets of water vapor and perhaps scoop some material from those geysers and analyze the molecular composition of that material. And that could inform us whether there is potential evidence for complex molecules that indicate that life exists under the surface. The more difficult approach is to drill, land on Europa and then drill all the way down. And that requires much more energy, much more sophistication. Nature provided us with these cracks that allow us to get a glimpse as to what may happen under the ice. And we should look into that. Now, of course, any form of life that exists just in liquid water without any rocky material nearby, as you have on Earth, would be probably much more primitive than we have on Earth, because it's thought that complex life on Earth emerged from the interface between rocks and liquid water. And just having liquid water, an ocean world, may not lead to complex life forms the way we find them here on Earth. But any form of life would be extremely interesting because it will tell us that we are not alone in some sense.
And the search continues. And that actually leads on really nicely to this, because until fairly recently, science ruled out anything being able to survive in extreme cold. So if we look out to us that far into the universe, it's not exactly a warm day in summer like we experience here on Earth. And it was found not to be the case right here on Earth. Am I right in saying that small worm-type creatures were found to survive in extreme low temperatures and also not just survive but reproduce within solid ice?
Yeah, that raises the possibility that perhaps icy objects out there may have life surviving in them as they travel between planets, for example, in a given planetary system. So you can imagine objects coming to Earth from, for example, Mars, and vice versa, and surviving the cold conditions in space. And so that's called panspermia, where life can be transferred on rocks. And of course, one can imagine also exchanging life between stars this way. We don't know if it happens. One thing to keep in mind is, even if you restrict life to the surface of planets like the Earth, we now know that about half of the sun-like stars have a planet roughly the size of the Earth at roughly the same separation. So actually the Earth-Sun system is not very rare. And that means that, since most stars formed billions of years before the sun, that in fact there could have been something like us that predated us. And the only way to find out is by searching for any relics that technological civilizations may have sent into space. That's a very different approach than we used in the past when we were looking for radio signals. In order to detect the radio signal, it's just like trying to have a phone conversation. You need the counterpart to be active at the time, and it needs to use the same technology as you are using. But if they sent equipment into space, it's just like plastic bottles on the surface of the ocean. We can search for them at any time, even if the sender is not alive anymore or using a different technology by now. So my point is, we are likely to find something if we just search. If we decide that we know the answer in advance, of course, we won't find anything.
Now, there is a difference between water or ice found on Earth and what's believed to be different within space. What is the difference, and how would that affect chances of how we know discovering living organisms to be?
Right. So the first thing to know about water, which is really essential for life as we know it, all the chemistry of life as we know it is in water. And for liquid water to exist, you need an external pressure of an atmosphere like we have here on Earth. If you were to take a block of water ice and put it in space and warm it up, it will go straight into gas, straight into vapor, without going into a liquid phase. And therefore, the chemistry of life would not be possible. So now you ask, okay, where can I have liquid water? Well, it's only on a planet, a big enough object that can maintain an atmosphere. And it turns out that we have next to us a neighbor called Mars. And the main difference between Mars and Earth, even though they are roughly the same distance from the sun, the main difference is that Mars is 10 times lighter, and it was not able to maintain its atmosphere. So it lost its atmosphere, even though early on it had an atmosphere, and we believe it had liquid water on the surface. We see the evidence of that. The Perseverance rover is now going in a delta, probably created by a river of liquid water. So we have evidence that there was liquid water on Mars. There was an early atmosphere, but then the Mars was not massive enough to retain the atmosphere. So it lost it. And once it lost it, it became a desert. So all the liquid water evaporated, and we can search if there was life early on Mars, but right now, we don't see anything crawling on the surface. There is no liquid water. And the lesson of that story is you need a planet roughly the mass of the Earth in order to retain the atmosphere. The Earth did it, and so you can't have an atmosphere on objects much smaller than the Earth, much smaller than what we enjoy right now. And so the lesson from that is, we could imagine liquid water, chemistry of life as we know it, on planets roughly the mass of the Earth, around other stars, but not much smaller. So if you imagine, for example, asteroids, they are much less massive than the Earth. They cannot retain an atmosphere. They cannot have liquid water on their surface. However, you could potentially have ice on the surface, and then deep in the interior, you can have liquid water, like we were talking about before in the case of Enceladus or Europa. That is possible because the interior is warmed up, for example, by radioactivity. So you can keep liquid water in the core of an icy object that is embedded in cold space, and whether life exists in such conditions is to be found. That's something we should examine and search for. But it will not be the same as life on Earth in the sense that there wouldn't be any rock touching oceans that could allow the complex forms of life as we know it.
And that opens the wider question, which there's also another time to talk about this, is how water ever arrived on Earth, and another great debate for another time. Earlier in the year, there was so much chat about your suggestion of the first interstellar visitor to Earth, which, if I remember correctly, that was back in 2017. Some people listening to this might have just opened their eyes a little bit wider and said, wait, what? Did I miss that? What was that all about? For those that aren't aware, tell us about the details of that potential interstellar visitor and why it's so significant for you within science.
Yeah, so this was the first object spotted near Earth that came from outside the solar system, and we knew that because it moved too fast to be bound to the sun. It was discovered by a telescope in Hawaii called Pan-STARRS, and this object was given the name Oumuamua, which means a messenger from afar, arriving first in the Hawaiian language. And it was discovered in October 2017. And at first, astronomers thought it must be a rock of the type that we have seen in the solar system, but it didn't look like a comet or an asteroid in the sense that there was no cometary tail around it. The Spitzer Space Telescope looked very deeply for any traces of carbon-based molecules or dust around it. There was nothing. There was a very tight limit on a cometary tail, and as a result, it's not a comet, definitely not a comet of the type that we have seen. And then people said, okay, well, maybe it's just rock, not covered with any ice, so nothing evaporates from it. The problem is that as it was tumbling every 8 hours, the amount of light reflected from it, sunlight, changed by a factor of 10. And that implied a very extreme shape. And analysis of the variation of light as it was tumbling implied that it was most likely disc-like, pancake-like shape. And then it exhibited an excess push away from the sun that could not be explained by the rocket effect because we didn't see any evaporation. So the only way I could interpret that was a reflection of sunlight is pushing it. And for that, the object had to be very thin, less than a millimeter. And the only way I could understand that is if the object is sort of like a sail that was manufactured by another civilization. And I suggested that maybe it's artificial in origin because nature doesn't produce such objects. In September 2020, there was another object discovered by Pan-STARRS, the same telescope, that shared the qualities of Oumuamua. It exhibited an excess push away from the sun by reflecting sunlight without any cometary tail, no evaporation. And then it was found a few weeks later that this is actually a rocket booster that we launched in 1966 to the moon. And we know that it had thin walls, and that's why it had a large area for its mass. So here is an example of an artificial object that behaved just like Oumuamua, and we know it's artificial because we produced it. The question is, who produced Oumuamua? And I should say that's not a philosophical question. There are philosophers trying to argue by abstract reasoning that Oumuamua could not have been artificial. And I say, we made this mistake 4 centuries ago when philosophers argued that they don't want to look through Galileo's telescope because they know the answer. They know that the sun moves around the earth back then. And they were completely wrong. So we shouldn't repeat that mistake. We should find the answer through our telescope. And that means trying to get a high-resolution image of a future object that looks just like Oumuamua, behaves like Oumuamua, looks different from any comet or asteroid we have seen before. Because otherwise, it would be like a caveman finding a cell phone and arguing based on experience that the cell phone must be a rock of a type that we've never seen before. And of course, if the caveman throws away that cell phone, then that would be the end of it. But if the caveman presses a button and records his voice, and then presses another button and records his image, it will become clear that this is not a rock. And we should do the same. We should just get more data on a future object of this type and perhaps press some buttons.
Yeah, well, you've certainly pressed some buttons by suggesting what it might be as well, which is great. I was thinking as you were talking there that there's one simple answer as to some people might ask right now, so why have we not seen any more of these? Well, my answer to that would be is because we weren't looking enough. And over the last, if you think about science in the last 100 years, it's come on so much in our technology to be able to search and look into places where we never thought possible 100 years ago. And I'm excited about the next 100 years to come based on the foundations we've laid there.
I mean, the answer is, again, quite simple. There is nothing philosophical in this. The Pan-STARRS survey is the first one where we had a survey of the sky and were sensitive to an object the size of a football field that reflects sunlight within the orbit of the Earth around the sun. So the reason we haven't seen that before is because we didn't have a powerful enough telescope to survey the sky and look for objects of this size reflecting sunlight within the orbit of the Earth around the sun. Okay, smaller objects, by the way, reflect less sunlight, so Pan-STARRS could not have discovered them, and there might be many more of them. So the point is, we are limited by the instruments we're using.
Yes.
And of course, you can always say, I don't want to look through my window. I don't have neighbors. There is no point in looking through my windows. Well, it's a self-fulfilling prophecy. If you don't check, you will not find them. And by the way, not looking through your windows will not get rid of your neighbors. That's something to keep in mind. Just like the philosophers not looking through Galileo's telescope didn't make the sun move around the Earth. The Earth continued to move around the sun. We use it for space missions right now. It's obvious. We could have taken one of these philosophers on a space flight and demonstrated to them, looking from afar, that the Earth moves around the sun. They would have seen it and they would have agreed on this fact. So the fact that we're completely misled by prejudice 4 centuries ago, is their problem. They preferred to remain ignorant. We can prefer to remain ignorant, not use the most sophisticated telescopes because we believe that we know the answer, which is pretty much what was happening until recently, where no search for relics of extraterrestrial civilizations was made. And for me, the change was the discovery of Oumuamua. I was basically guided by the evidence which showed that this object is anomalous. All of this is detailed in my book, Extraterrestrial. And as a result of that experience, I inaugurated the Galileo Project. To celebrate Galileo's approach. In July 2021, I received the funding at $2 million from people who were inspired by my book. I didn't do any fundraising, but that much money allowed me to establish a project which now has more than 80 scientists involved in it, where we are trying to build telescope systems that will find objects like Oumuamua in the future, but also objects closer to Earth. For example, those that were reported by the Office of the Director of National Intelligence in the US to the US Congress on the 25th of June, 2021. These are objects whose nature is unclear, and they do not behave the way that our technologies allow us to understand.
You make life easy for me when you include all that information, because some of that I had ready to ask you. So I'm grateful for that. So you mentioned there, you touched on the Galileo project, and you are involved and have been involved in a number of projects. One that I'd like to ask you more about, though, is the Starshot initiative. And how did you get involved? And what is it all about?
Yeah, so in May 2015, an entrepreneur from Silicon Valley named Yuri Milner came out of a black limousine next to the Center for Astrophysics at Harvard University and entered the building, sat on the sofa in my office in front of me, and asked me whether I'm willing to lead a project whose goal is to visit the nearest star system within our lifetime. And I knew that since his age is the same as mine, I knew that he's talking about getting there within 2 decades, and it takes light 4 years to arrive across that distance to the nearest star system. It's 4 light years away. So that means that we need a spacecraft that moves at a fifth of the speed of light if we want to get there in 2 decades. And that's 1,000 times faster than the chemical rockets that we have launched since Sputnik. And all of them were 1,000 times slower than we need in this context. So I told Yuri I need some time to think about it. And 6 months later, I reported back that the only technology which seems feasible is the light sail technology, which means that the spacecraft doesn't carry its fuel with it. It's being pushed by light, just like the sail on a boat, which is pushed by wind. You can imagine light bouncing off a very thin film of material and giving it a push. And in principle, the advantage of that is you can push the sail with a powerful enough beam of light. You can push it close to the speed of light because you're pushing it with light. And the only issue is you need a laser beam of 100 gigawatt, roughly, shining on a sail that weighs a few grams, roughly the size of a person, over a few minutes. And then you can bring it to a fifth of the speed of light across a distance which is 5 times the distance to the moon. So that's the concept that we came up with, and it defined the Starshot initiative. And currently we're examining the technologies needed to make it real. And that includes the laser system, the sail, and the communication between the spacecraft and Earth, because we're talking about vast distances.
You've just made me a little nervous there because my son is 6 and I'm thinking the equation you just came up with is probably what he'll come up with as homework in a couple of years' time. So I really need to bring myself up to speed with that. It's really great the way you've just explained that to me and everybody else. I really appreciate that. And what a delight to be involved in that and to get your teeth into, it's like going into a sweet shop for you, I'm sure, and thinking, okay, endless tools. This is fantastic. Over the years, there's been pilots reporting information, sightings of unexplained objects in the skies, oceans, sounds, etc. Now, related to this, a relatively new element has appeared on the periodic table, M115. What can you teach me about that? So tell me a little bit about that element, and also related to the discussion we were just having to do with the Starshot initiative, because the two may be related in the future.
As far as I know, the periodic table is pretty much complete in terms of all the elements that could be stable. And of course, in colliders of heavy elements, you can end up making, for a short time, an element that is heavier than the heaviest element that we have in the periodic table. But these giant nuclei are not very stable. As far as I know, we haven't yet found evidence for materials that are not familiar to us, you see. So now, of course, it's possible that our understanding of physics is incomplete, that in the future we learn something new as a result of an encounter with something that was manufactured by another civilization. And that's what makes it interesting as a learning experience, and we should be open-minded. But as of now, the laws of physics, as we know them, seem to apply under all circumstances. The standard model of physics is holding quite well. But there are some aspects of it which are incomplete, for sure. We don't have a theory that unifies quantum mechanics and gravity. We don't understand what most of the matter in the universe is. It's called the dark matter. So there is matter. We definitely know about it. It's 5 times more abundant in terms of the mass budget than ordinary matter that we are made of. We don't know what it is. So you were talking about an element in the periodic table, but I'm saying there is something completely different that is not familiar to us. And we don't know what particles are making it, and whether it's particles or maybe something else. So that's called dark matter, and it's still an enigma about almost 80 years after it was conjectured first by Fritz Zwicky. And we know that it exists if we believe the laws of gravity that are included in Einstein's theory of gravity. And so there is still to learn, a lot for us to learn. And one way to learn is doing it, trying to figure it out ourselves. But another one is to look over the shoulders of a smarter kid in class, in our cosmic block. And I'm very much in favor of that. If we encounter some relic of another civilization that predated us by 1 billion years and by now knows the answer to many of the questions that bother us, for which we don't know the answer, I would be much in favor of getting a leap forward by learning from those smarter kids rather than trying to figure it out ourselves. It would save us 1 million years or more.
Yes.
So I don't mind, the blow to our ego. You can imagine, for example, the Perseverance rover on the surface of Mars finding evidence for very primitive life that existed on early Mars, like microbes. And of course, everyone would be happy because we feel superior relative to those microbes. We are intelligent, they are not. But imagine Perseverance bumping into the wreckage of a spaceship that represents technologies that are far more advanced than we possess. That will be a blow to our ego. I'm sure a lot of people will feel upset about it because we are no longer the smartest kid on the block.
However, everyone has their thoughts and feelings on how they approach things, and I'm with you on that because you do learn more from the smart kid behind you sometimes, as you put it, and it's how you take that forward together. And sometimes I do feel there should be a little bit more togetherness as a whole. What's your feelings about science releasing information to the public and the sense of responsibility science has to provide that information for the general public?
Yeah, so the reason I established the Galileo project is so that, first of all, we will have full control over the instruments we're using. So we will know exactly how the data was collected, and obviously that will be open to the public. Until now, the identification of the reports about unidentified aerial phenomena or unidentified flying objects were mostly classified based on classified data, because the data was collected by classified sensors that the government is afraid of exposing because they are used for national security purposes. And obviously, at least the US government prefers the adversaries not to be aware of the technologies being used. But if you are conducting a scientific experiment, and I should say the sky is not classified, you can look at the sky, astronomers do it all the time. And if you're looking at the sky with instruments that are bought off the shelf, there is nothing classified about them, then the data will be open to the public. And that's the rationale behind the Galileo project. We will collect new data from instruments that we have full control over. They are not cameras in a jittery cockpit of a fighter jet. We know exactly where the cameras were located and what they were doing when the data was collected. And then we can analyze it just like a scientific experiment. And I believe that the data should be available to the public. I don't want to look at classified data because that would limit my freedom as a scientist. And so science is about reproducibility of results. The fact that anyone can reproduce the results if they were doing the same thing at the same time. And that's what the Galileo project will try to find, if there are some phenomena that are recurring and what the nature of these objects might be. Because I think, once again, if you have a big enough telescope, you can get a high resolution image of such an object that is cataloged as UAP in the Pentagon report to Congress. And if we get a megapixel image of an object the size of a person at a distance of a kilometer, which is possible with a 1 meter telescope, then you can resolve the head of a pin. You can tell the difference between a label saying made in country X here on Earth, and versus a label saying made on exoplanet Y. And it's all about having good enough data. This is not a philosophical issue. And so my hope is that and we are now starting to purchase the instruments that we want and put them together and test them within the Galileo project. My hope is that within a year, we will be able to start collecting data, at least with one telescope system, then make many copies of it and put them in different locations and try to shed some scientific light on the nature of these objects. And once again, this data would be completely open to the public and the analysis would be transparent the way it's done in science.
So just going back to what I've heard of then regarding the element 115, is it fair to say that that may be something that is around but cannot be sustained into anything less than what is just less than a millisecond in its form, like a lot of elements that perhaps that we cannot classify as a sustainable element? Is that more of an accurate way of describing something of that nature?
Yeah, I mean, you can make transient structures of things that are not stable, but you cannot have an engineering project building things out of them. That's the issue. So, but as I said before, our understanding of nature is incomplete. We know that because we don't know what the dark matter is made of, and depending on the nature of the particles that make it up, there might be some engineering prospects to that. Maybe you can put these particles together in a way that is not familiar to us.
Now, there's been a release in an article today that's caused a bit of an upstir. It's actually quite good timing that we're recording this today. So tell us a little bit about that article and why you believe it's caused a bit of an upstir in the world of science.
Well, I really didn't mean that. I wrote this essay for Scientific American just as an interesting thought, and then apparently there is a lot of interest in it. And what I try to discuss is, we know that the universe started from a big bang, and we see all the evidence for that, but we don't know what predated that, what was there before the big bang, and why did the big bang happen? That's a fundamental question. And of course, people try to explain the Big Bang in various ways. Maybe it was just a fluctuation of the vacuum that, by chance, our universe was made out of a vacuum fluctuation. Maybe a lot of universes are popping up everywhere, and then one of them is ours in the landscape of the multiverse, so-called. Or maybe, we are connected to what happens in a black hole. Like if matter falls into a black hole, then it goes through the singularity and makes a new universe out of that. There were all kinds of, or maybe it's universe is bouncing. And it goes through cycles where it contracts and then bounces and creates a big bang, and then it will contract again and bounce again. So that's a cyclic universe. There were all kinds of suggestions. But what I thought about is a completely different scenario, where I said, once we develop an understanding of how to unify quantum mechanics and gravity, we might understand how to create a baby universe out of nothing. And that is possible because what we are missing right now in understanding how to make the Big Bang is a theory that unifies quantum mechanics and gravity. We know that Einstein's theory of gravity is incomplete. String theory is trying to do that, but it hasn't yet converged to a predictive theory. But let's imagine a future time when we would understand how to unify quantum mechanics and gravity, and then we will know how to make a Big Bang. Now, if we can create it in the laboratory, that offers a completely new possibility, because you can imagine that our universe was created in a laboratory by another civilization, a very advanced civilization, more advanced than we are. And then it created a baby universe, maybe our universe. And in that baby universe, you can imagine another civilization that is of the same level creating another baby universe. So it's just like imagining chicks hatching out of eggs, and each of those chicks is creating new eggs, and that's the cycle of life where you have multiple generations, and it can go forever. It could go forever. It could also not go forever, like in the case of the chicken and egg dilemma, which is solved by saying that something else predated the chickens and the eggs. But in principle, you can have an infinite series of a universe giving rise to an intelligent civilization that knows how to make a baby universe inside and creates another Big Bang that makes another civilization of that type, which makes another universe, and so forth. And this can go forever. And you may ask, okay, well, why would the universe lead to a civilization that can create another universe? And the answer is, just like in Darwinian selection, only those are the universes that survive forever because, they make many generations. And so there is this Darwinian selection of only a universe that leads to a civilization creates babies that lead to more babies and so forth. And we haven't yet reached that milestone of being able to create a universe in the laboratory. But I'm not worried about that because, whenever I teach a class at Harvard, I tell the students, half of you are below the median of the class. This is just a statistical fact. The median is defined such that half of the class is below it. That's the definition in statistics of the median. And the students get upset because they all think that they're at the top 1% of the class. But there is this fundamental fact, irrespective whether you are a Harvard student or not, that half of the people are below the median. That's a fact. You cannot deny it. It doesn't matter how good you think you are. So I tell them, half of you are below the median. And they get upset. And
it's one way of encouraging social distancing. I mean, they're going to walk out and you can have a lot more space. I mean, it's a great idea.
No, but when I apply it to our civilization, I would say, we are most likely to be in the middle of the bell-shaped curve of the probability distribution of intelligent civilizations. And there must be a smarter kid on our block. So the fact that we are unable to produce a baby universe right now, to me, doesn't say much because I think it's quite likely that there is another civilization that is far more advanced. And the point is, our universe just needs one such civilization, which I call type A, that is capable of making a baby universe, because then a new universe will be created. You don't need more than one. And we are not that one. That's okay, because we're in the middle of the class, kind of. But another civilization may have done that. The reason it attracts a lot of attention is because it touches on religion, right? Because it says basically that if you're able to create a universe, and if you are able to create, let's say, life inside of it, these are the qualities that we assigned to God in many religions. And my point is that if we ever meet a civilization that is capable of creating universes or life in them, then that civilization will be a very good approximation to God. And that civilization is just a very advanced scientific or technological civilization. That's all.
That's an interesting way of looking at it, because you're not ruling things out. You're saying in a company too, it's about how things are approached in the future. When you were talking to me then, I was thinking about something that I saw recently that's a great thing to talk about now. Our nearest star system is Andromeda. Okay. Now, as far as star systems are concerned, that's a fairly small star system. And the one thing that I learnt, which I'd love you to elaborate on, is when star systems, when we look at their positioning, obviously they don't stay in the same place, and some may impact our star systems in the future. So for something of such a small size as Andromeda, it's not supposed to cause too much of a problem or interference with our star system and our universe. But what about a larger star system that we know to be lurking there somewhere in the universe? How would that affect our universe if it came into contact with us?
Well, so Andromeda is so-called our sister galaxy. So our galaxy is the Milky Way. There are hundreds of billions of stars in it. That's called the Milky Way because you can see a strip of stars. Most of the stars are sitting in a disk and we are in it. So it looks, just imagine looking at a plate that is edge on, you would see a strip in your field of view, which relates to the plate. And that's what we see in the sky in terms of the Milky Way galaxy, which is a disk-like galaxy. And Andromeda is very similar. It's also a disk galaxy, but it's on a collision course with the Milky Way. It's approaching us. And, I visited Australia and I was struck by the view of the sky there. And when I visited, at the time that I visited, I could see Andromeda, and it's approaching us at 110 kilometers per second, roughly, and that's a relatively high speed. So within a few billion years, it will actually, collide with the Milky Way galaxy. Now, most of the space between stars is empty, so not much will happen. There wouldn't be collisions of stars, for example, with one another. But what will happen after this merger takes place is that the stars will be redistributed, will be mixed up, and you will end up with a galaxy that is football-shaped. These are called elliptical galaxies, and we see them. They are the results of mergers of this type. And the sun will likely be tossed away from where it is right now to the outskirts of what I call Milkomeda galaxy. So I wrote the first paper that tries to forecast what the outcome would be in a few billion years of this merger. And this is the only paper of mine that has a chance of being cited a few billion years from now, because it will be compared to the actual view on the sky, if there is anyone left to look at that. By the way, the sun will not necessarily die by then. So we're talking about a collision between the two galaxies that will take place before the sun dies.
Because our theory is it's more like double the time of that for the sun to use all its energy up, basically. So
right.
But that's not good news for people then at that point in 2 billion years living on Earth, because you've kind of just flipped the universe on its head, and people out in the cold depths of space there on other planets are saying, well, it's certainly warmed up down this end for us.
Well, so one thing I should say is the sun, is evolving, obviously, and within 1 billion years from now, the sun will warm up. Its surface will basically be more luminous than it is right now. It will change. It will grow in size, and that will boil off all the oceans on Earth through a greenhouse effect. And so nothing on Earth would survive in 1 billion years, irrespective. We're talking about global warming, we're talking about all kinds of risks. Those are in the short term, but within 1 billion years, we won't be able to survive here. And if we want anything to be left, currently all our eggs are in one basket here on Earth. We would have to move into space. And that's the future, that we have to think about it. We have some time, but at the end, I think we will have to build platforms on which humanity can survive in the long term.
If we had the technology in the future, which I'm sure you've probably fantasized about, as I have, to be able to look back in time, how proud would you be, looking back 1 billion years and say, hey, I wrote the paper on that and we listened?
Well, I should say we were not that good in bragging in space. First of all, you see entrepreneurs like Richard Branson or Jeff Bezos using their wealth to lift their body by 1% of the Earth radius, which is really nothing. The size of the universe is 10 to the power 19 times bigger than the radius of the Earth. So, showing off in space is an oxymoron. If you just lift your body by 1% of the Earth radius, that's nothing to brag about. But even if you go back in time, we sent, for example, the Golden Record with Voyager, where we put some the Beatles, some other things that we are proud of about our culture. I think if an extraterrestrial would look at that, they would not be very impressed. In fact, they might steer their spaceship away from Earth. But even worse than that, the New Horizons mission wanted to celebrate the contribution of Clyde Tombaugh, the scientist who discovered Pluto. So they put some ashes of his body on New Horizons that is making its way out of the solar system. Now, This is the wrong thing to do, because what are ashes? They are burnt up DNA. You take the DNA of a person, you burn it up, you destroy all the information. The ashes are no different from the ashes of a cigarette. And you put that on a spaceship to celebrate the person. If an extraterrestrial would find it, they would laugh at it, because there is no information content in those ashes. If you wanted to celebrate Clyde Tombaugh, you would put an electronic version of his DNA on the spacecraft, or you would put a stem cell there. But NASA, which is full of scientists, decided to do the dumbest thing, which is to put ashes, basically burned up DNA of a person that it wants to celebrate. That doesn't make much sense. Doesn't reflect very well on our science. So I'm not really happy about the way we brag in space as of now.
It's more of a sentimental thing, I think, by the sounds of it, rather than let's recreate the person that discovered Pluto. But yeah, it's your analogy is almost like turning up at the barbecue too late, really, isn't it? To not put too crude a point on it, to be honest.
No, well, I would explore space with modesty, a sense of modesty, just trying to figure out, what can we learn from those that are smarter than us, rather than brag, which has been the trademark of humans so far.
So from that, then, I get from you the money could be better spent for you looking around and learning about what's deeper and further out there than going on adventures, because there are a lot of people with a lot of wealth on Earth, and that money, in your mind, could be spent better elsewhere.
Yes, definitely. What I would say is, if the Galileo project, for example, finds technologies developed by other civilizations, and we wanted to import those technologies to Earth, that could be worth a lot of money. So, for these wealthy individuals, for the cost of their flights, we could have funded the Galileo project in full. It requires tens of millions of dollars, and maybe for a space mission, hundreds of millions of dollars, to get all the science that the Galileo project aims to do within a decade from now. And what I would say is that the impact on humanity would have been huge, much more so than just, enjoying the view of Earth from a distance of 50 kilometers above the surface. I would say, let's try and find out if there was something much more advanced than we are, a billion years ago. And the way to do that is to look at the sky.
I'll just cross the question off. Will RV be booking his space flight soon? No is the answer to that. Let's move on. Ironically, I never really put that, but it's interesting. I guess it's a no.
I would be happy to go to space, I should say, because I enjoy nature that is unspoiled by people, and I jog every morning at 5 a.m. in the company of birds, ducks, wild turkeys, rabbits. And I like nature the way it is, and going to space is an opportunity to learn about what happened without humans, destroying their environment. And one reason I'm seeking for intelligence in space is because I don't often find it here on Earth.
That's a good point, which is why you kind of mingle out and about with the ducks and the whatever other wildlife loves to come along at that time of the morning. There's something about that time of the morning, and I kind of liken that to as close as you'll ever get to being in space where, assumably, it's very silent, and there's that, that nothing.
It's silent, and it's also dark. The one experience that astronauts reported when they leave the Earth is the blackness of space, something you don't see from the surface of Earth, because, the sky is blue, because of there are always city lights reflected off the atmosphere. And but when you go up to space, you really see blackness. Everything is black. Of course, it's not completely black, because there is some light emitted by all the stars in the Milky Way galaxy and in other galaxies very far away. So there is some light, but it's much dimmer than the lights we have here on Earth. But that's most of the volume of space has nothing. It's like empty. And there is something to it because, we live in a very busy environment, sort of like living in a city. There are things happening all the time. Once you go away from the city into nature, left on its own, it's a very different reality. And what I'm saying is most of space is a very different reality than the one we are used to. And just to illustrate it with an example, Enrico Fermi, 70 years ago, posed what is called now the Fermi paradox. He went to lunch at Los Alamos and said, well, if there are extraterrestrials out there, where is everybody? Now, to me, that sounds like a very presumptuous question. It's like sitting at home, enjoying your family and then saying, well, I don't hear a knock on the door, therefore I don't have neighbors. Now, the point is, our recorded history is only 10,000 years old, and that's 1/1,000,000th of the age of the Earth. So, how dare we say we don't hear a knock on the door, therefore we don't have neighbors? The point is, we have to figure out that it takes a lot of time to travel between stars. It could take millions of years, depending on the distance. And the fact that we don't hear a knock on the door right now when we are waiting for it doesn't mean anything.
So all the money, obviously, you agree, should be put into more scientific research, but you wouldn't pass off a free ticket from Richard Branson or from Jeff in the future to have a little look down from space to Earth.
Definitely. I would enjoy that. I'm just saying that in terms of my priority list, I want to figure out really, are we the smartest kid on the block first? That's more important to me. But going to space, I would love it.
I'm just going to flip something. So we talked a lot about space. However, I've not mentioned this. Shouldn't we have a standard protocol for first contact? And by that, if anybody doesn't understand what I mean by that, I mean, should we get a visit that we're not expecting here on Earth, what should be in place to be able to deal with that?
Definitely. And, people in the past, because we search for radio signals, there was not much urgency because, the nearest star is 4 light years away. So it takes 8 years for a round trip of communication. And most stars are much farther away. So if we ever detect a radio signal from an advanced civilization, we have plenty of time to decide what to do. So the protocol for responding to that is similar to the protocol for responding to a letter that arrives to you by surface mail that is very slow. Okay, you can take your time in responding to surface mail. But on the other hand, if you meet a person, in your backyard, you have to decide immediately what to do, how to respond to that person. And that is the experience of finding some technological relic that is smart, that is intelligent. And we can imagine that because we develop artificial intelligence that drives cars. So just imagine a system that we find from another civilization that is equipped with artificial intelligence. So it could be smarter than us, but it's just hardware. And the question is what to do with it. If we spot it, like with the Galileo project, if we see something advanced, moving around trying to collect information. What do we do? How do we engage with it? There is no protocol for that. It was not considered by any international committee that decided about guidelines. And I think it's something to think about, given that the Galileo project is trying to find such objects.
Is science, cosmology, and astronomy a little bit like trying to run a hospital? Well, where do you put the money into first?
Well, I would say that it's much simpler than that because we need to decide about priorities. What are the most urgent questions? And if you look at academia right now, it's not at all organized in this way. There are large communities of physicists talking about extra dimensions or the landscape of string theory, things that have no implications for our daily lives. And what I'm saying is this question of searching for relics from extraterrestrial civilizations is a subject that was not funded at all, okay, that has huge impact, potential impact on the future of humanity, that the public cares a lot about, and that is not funded at all. So my point is, first decide about the strategy, define the question that is most exciting to you. And if you were to poll the public and poll those people who have the wealth, I would be surprised if they wouldn't tell you that knowing if there is a smarter kid on our cosmic block is not at the top of the list. That is something that everyone cares about. People are fascinated by. The reason I say that is my book became bestseller, and it's translated to 25 languages. I had about 1,200 interviews over a period of 7 months. When I announced the Galileo project, I had thousands of emails from people willing to contribute from their expertise to the project. And I got funded without any fundraising. So it's obvious to me that this is a very important question. Everyone wants to know the answer to, but nobody in the past assembled a team of scientists that will try to address it. So what I say is our priority list is not really organized as of now. And I'm trying to say this question is really important for a lot of people, okay? And we should address it. So once you agree on that, then the amount of money needed to address this question is really not large. We're talking about tens of millions of dollars, maybe hundreds for a space mission. This is less than, the Large Hadron Collider, the James Webb Space Telescope. These projects required $10 billion. The best we can hope with such projects is to discover the nature of dark matter, for example, that will have zero impact on our daily lives. But think about it. If we invested $1 billion in the search for equipment sent by other civilizations, and we find the answer, that would have a huge impact on humanity, on the way we think about ourselves, on religion, on our aspirations in space. So how can we shy away from this question?
No, it's a really good point. I'll end on a fairly straightforward question. What do you believe to be humanity's biggest threat from outer space?
From outer space, it's probably asteroids. The same thing that killed the dinosaurs 66 million years ago. There was an asteroid, a rock the size of Manhattan Island. But I think the biggest threat to humanity is not coming from outer space. It's self-inflicted wounds. We are not careful enough to plan ahead. We are engaged in rivalries between nations. Some groups of people trying to feel superior relative to other groups of people, and that's not the best path to prosperity. We don't care about, in terms of policy making, we don't care as much about our environment as we care about, military confrontations or other, economic superiority. And so what I would say is we have a long way to demonstrate that we are intelligent, because the way I define intelligence is being guided by science. And the guiding principle of science is sharing evidence-based knowledge. So we are not sharing a lot. That was clear from the COVID-19 pandemic, that the data from Wuhan, China was not shared with the rest of the world. It could have saved a lot of lives. And the second thing is we don't base our policy on evidence very often. So I think we have a way to go, but I hope that we'll get our act together, because otherwise we may have only a few centuries left.
I think the word that I come up with over a previous discussion with one of the other chats I've had is the word trust, unfortunately. And that's a big deal. In the science world, there seems to be a lot more countries working together behind the scenes to a common goal. And much like you've just said, I just don't see that humanity's got itself into this situation where there's that big word of trust. And who's going to blink first?
Yeah, and if you think about it from the big picture perspective, it's a way of Darwinian selection. If we don't get our act together, if we behave in a way that is not very smart, then we are doomed to perish and disappear. Okay, and there were a lot of species that didn't survive throughout the evolution of the Earth, and okay, so what? The cosmos doesn't really care about it. Darwinian selection basically says if you're able to adapt to changing circumstances and in just the right way, then you will survive. And if we are not smart enough to do that, we will go away, and nobody would care. If you look at the vastness of the universe, who cares whether humans continue to exist or not? And by the way, there could have been a lot of other civilizations out there that were not smart enough, but those that were smart enough perhaps continue to exist.
So maybe some of the decision makers from across the world, as well as having the climate get together, should all book a ticket to the museum and have a look at the empty space available for a potential placement.
Yeah, I think our future is really in space. And moreover, we can learn something by finding others that predated us out there. And, we are, the way we behave always reminds me of my daughters when they were at home at a young age. They tended to think that they're the smartest in the world, that the world centers on them. And of course, that changed when we brought them to the kindergarten and they met others. And I very much hope that our civilization will mature. And the way to do that is by meeting others.
That's a lovely way to finish up. There's so much information that you've provided today, and you can find out more about R.V. Loeb's work, projects and publications, including the best-selling books like Extraterrestrial. Just type in AVI Loeb into your search box and it will all come up. R.V., it's been a real pleasure. I know your time is valued by me and everyone listening, so thank you for speaking with me today.
Thank you, Steve. It was a great pleasure.
You've been listening to Steve Reed Chats, Series 1, Episode 3, with R.V. Loeb. And it was truly gratifying to speak with a pioneer in the search for intelligence in such depth. A conversation I'm going to always cherish. You can listen back to the first series of Steve Reed Chats right now. Maybe you've not heard my chat with Nick Pope or the paranormal episode with Heather Tuddy. I'll be back with Series 2 of Steve Reed Chats about a different subject in the near future. Subscribe and turn on your notifications, and you'll always hear about the latest episode first.